Thanks for stopping by the shop. As you know, I'm Chuck, and this video tonight is longer than my typical, and I hope it will help hobby machinists like myself learn. That's part of the whole thing of my channel is I like working, I like the entertainment. I hope you guys are entertained, and hope there's some education in it also. I'm learning all the time and I really enjoy it. So hope you enjoy, and let's get on with the video. Hello everybody, welcome to the shop. So this is my adventures in Acme threading. Maybe a two-part video, but we'll start here. So as you see, there's an two Acme rods here. This one is from my friend Flea Market Dave. In a past video, we showed the radial arm drill press that he had purchased, and this is the Acme rod that lifts and lowers the table. This is the nut that was built into it, and you can see this extreme rust right here. Well, this pocket held water, and these threads were down in the Acme nut there. So he opted to look to change this out. His first purchase, he bought, this is a 4 TPI Acme thread. He did buy a rod, another length, but it was a 5 TPI. And subsequent to that, he ended up purchasing this rod from the honey hole guy. And as I mentioned, this is a 4 TPI. Well, this is an 8 TPI over here. Well, to move on with it, he was looking to rebuild this unit, and he needed nuts for the rod, the shaft. So he went and purchased two units here, and they were both listed as 8 TPI units. And showing you here, they thread on and then they lock. Can't go any further than that. So the quandary started. Is this really an 8 TPI shaft? It's obvious it came out of a lathe or a mill. When you look at the complete shaft, it was out of a machine. So then the question is it metric? Is it standard thread? Not having any gauges myself for it at the time, if you took a scale and you measured, it measures 8 threads per inch. So what I ended up doing, and I think I've had some photos I'll show you, I ended up, and you can see it on this unit here, I ended up melting wax and pouring wax into this unit here. So I poured wax into this unit here, and then I backed the wax piece out, and so I actually have a wax template of the inside of this threaded collar. That allowed me to hopefully measure and compare to this rod right here. And there's a couple shots here, still shots on my optical comparator, as I was trying to assess why this threaded collar didn't fit. I have to also mention my good buddy Carl. If you've seen on my channel many times, we always consult, and I had him over here, Carl's Consulting, and we did talk about this and worked on achieving what it was. Best guess, an 8 TPI, but for some reason this guy doesn't fit. Subsequent to that, I went on eBay and I bought a Acme screw pitch gauge, And with this guy, I could double check that this unit here was an 8 TPI. So kind of answered the question there. Again, why doesn't the nut fit? Played around trying to look in there, see why doesn't the nut fit. So now starts the adventure. He says, okay, well, I'll make nuts. I'll do it. So I've watched videos all the time. So I went and saw Keith Rucker. He made a left and right thread, and he had showed going to this edge, engineer's edge, for the information. You put in what you want. So this was a 1-inch shaft, 8 threads per inch, and it gives you all the data what you need to know. And the depth of the cut here is 62.5 thousandths. We'll get to that though. So hey, I was all set to go. Well, figured let's start on plastic first. Why? I got a lot of Delrin and different things, and let's go ahead and try some plastic. So hey, there we go. Had it blued up, got it in the Monarch 10EE, which we'll talk about that. What a pleasure it is to use that to do this. And hey, I cut the thread. Went to 62.5 thousandths deep, and oh, hey, nice job. It threads really nice, but old Charlie got confused. So hopefully this shows up. It happens to me every time on threading. Major diameter max, 1 inch, 40 thousandths. Hey, well, Charlie made this 1 inch, 40 thousandths. That's why it goes right over it, stooge. So that was a waste, but Charlie learned. Okay, so now I know it's 7/8 of an inch is my internal diameter. That's where I start. So I go back at it again. Here's another one that I cut. This is out of a product called Turicite. I just picked up a whole rod of it and starts to go on. Won't go any further. Yeah, that wasn't good. Let's try another one. Whoops, hit the. Hey, this one. No, it starts to go on, but I'm still cutting it at 62.5 thousandths, right? Hey, this one a little more. Another fail. Why are all these fails? Well, we'll get to that in a second. So here's another one. How about this one? Hey, success. Look at that. Not a problem. So let's talk about a little bit of the success here. How did I do it? Well, luck. I'll say that in this. It started off with a lot of luck. Why a lot of luck? Well, this was the first boring bar with the Acme insert in here that's been ground, and I didn't grind it. And I was using this tool here. Well, I did a little more checking, and the tip of that tool is supposed to be 46 thousandths. And it's under, again, on the comparator, I could really check it, and it was under 46 thousandths. So I changed tools. And here you can see in the holder here, there's another high-speed steel insert there. And you can see it's held in with a set screw. Well, it's not very long. And I'm honest, a couple times, why some of these failed was the actual insert came loose. But let's go on here. So I managed to get this guy to work. Hey, I can do it. All right. Still have the original one that doesn't fit, right? That's locks. So I say, heck, I can go in and clean up he had 2 of these, 2 of the ones he bought. So, hey, I can go in and pick up this thread and I'll make it fit. Hey, not bad. Well, almost not bad. Well, what did I do here in my learning experience? what I did was when I cut this guy, I went 72 thousandths instead of 62 thousandths. And so I ended up on this one doing basically the same thing. Now I had to pick up the thread and do my best guess where I was, and so I got it to go on, but it's a little loose. Yeah, now why did I do that, Charlie? Well, someone was kind of lazy or stupid, both. I wouldn't take my tailstock off the lathe. So I was pulling all these various units out of the chuck, going back in, picking up the thread, and recutting again. So I finally, after I did this, I said, okay, goof that one up. Now I got to make one. So got a piece of steel that I have here round, and said, okay, I know now. I know how to do this. 7/8 bore and 62.5 thousandths deep, and let's go. Well, let's go back to my tool here. As I was progressing on cutting this guy, and you'll see that it fits, right? Ran into some problems. One, you can see the tool is held in with a set screw. Well, the pressure on cutting the plastic was no problem. The pressure on cutting steel, and it happened actually on this one also that fit loose, the tool moved. So on this guy, right, the one that fits but it's loose, I had to go back in, pick up the thread after the tool came loose, da-da-da-da-da. On this one, the one that's out of my own material, same thing happened again. I'm just a hard learner. It came loose again. Actually, at one point, I actually crashed into the piece right here. Had a lot of problems, a lot of learning. So what did I do? I said, stop this stupidity, and I silver soldered the high-speed cutter into the end of this. So now it's not going to move. That solves the problem. Thank you, Keith Fenner. That's where I learned my silver soldering lessons. And so been using this tool, and now why does this guy fit finally? Why does it fit? Well, Charlie finally took a tailstock off the lathe, so now I can fit the shaft to the nut and sneak up on it. And this one's got a little play in it, and I think a little bit of the play there is due to the various picking the thread back up after the tool crash. So I will be making 2 more probably. I have enough material to do it, and we'll finish up and make Dave as blanks. So we'll probably see a little bit over at the 10EE and show you that. Now back to this shaft. It's Dave's not planning on using it, and basically it's trash. So I'm planning on cleaning this up, welding or brazing it back up, and then recut the threads, just for learning. Maybe he'll end up wanting to use it and keep it stock. I don't know, but that's my plan. And let me shift the camera over here a little bit, and we'll look at. Let's see. Well, maybe I can. How can I do? Oh, I'm gonna move the camera here. There we go. So, when this all started, talking to my buddy Carl, he said, "Do you have any Acme tooling, or are you going to have to grind your own?" And my first comment was, "Oh yeah, I got a bunch of it that I didn't grind it. That's all the stuff that I've bought over the years. And as I dug, I really didn't find much. But I did find, in the sense of boring bar inserts, these two guys which are the number 8s. I borrowed this unit from Carl, which you can check units, and all these various high-speed steel tools I had, and so I've got tooling to cut a 2 Acme, a 2.5, a 3.5, 3.5, 4, 4, 4.5, 5, 6, and 10. Now these would all be outside turning, unless I was to whack it off and make it fit in a boring bar, which basically that's what this guy was. It was a cutoff, and that's how I did that one. It was a tool just like this. So anyway, there's my adventures so far in Acme threading, and we'll see you over at the lathe here. Okay, we're over at the lathe. It's a Monarch 10EE 1953 model. Love the machine. So talk a little bit about the setup that I'm using here. My machine has the ELSR, electronic screw reverse, and so it's basically I have two levers here for engaging the spindle. Once the ELSR is engaged, then this is locked out. It doesn't do anything. And this up and down here is your forward and reverse. There's the half nut lock, and you can see a stop there on the far side. You can set stops for the carriage to stop. And I've showed it in a previous video. If you don't change the speed of the spindle, this carriage stops each time within a half a thou, maybe even less than that. It's really accurate. So can work close to the chuck once you get everything set up. The other nice thing that the lathe has here is that it has a stop. So when you pull back out, it stops. It's set by this thumb screw here. So when you come back to your cutting position, either direction, in or out, you always go to the same place. It takes a lot of pressure off of threading, because I used to always get confused. How much did I back out? Did I back out enough? It really makes it simple. With the ELSR, once you start threading, you leave the half nut engaged, so there's no more trying to pick up the half nut on the dial there. It takes a lot of pressure off of threading. If you were threading something very long, yeah, then you would probably go ahead and pull the half nut and move the carriage faster. For what I'm cutting, an inch, you just leave everything engaged. So basically, all you're dealing with is this and your compound. Now you can see I have a dial indicator set up here, and again, learned this one from Keith Rucker, watching him. But as I mentioned earlier, the depth of cut is 62.5 thousandths, and you can't use the angle. You have to go straight in for that 62 thousandths. You're feeding in with an angle, but you have to read on the 90 degrees. So hence, that's why the dial indicator is set right there. And as I was just coming over and I put the lathe tool back in, I went, oh, I forgot to, in my comedy of errors, one of my times when I was threading one of those pieces, and I think it was the steel, I don't remember, I put the tool in and I didn't lock the tool in place. So as I started the cut, of course there was a large movement, saw it on the dial here, and what the hell happened there? I didn't catch, still hadn't caught, because it kind of pinched everything. I still hadn't caught that I didn't lock the tool post. Those things happen. That's a bozo. I don't know if that's a stupid, that's a bozo. But anywho, here we are. So I think what I'm going to do, and it's hard for me to film for you guys, but I'll see what I can set up. What I'm going to do is take the threaded collar that Dave has purchased that I show that doesn't fit on the shaft and see if we can get that to fit on the shaft. As you notice, the tailstock's not there, so I can fit to it, and we're going to attempt that. Now, how I do it, how am I going to pick up that internal thread? Well, let me get the part over here and we'll talk about that. So this is how I figured out, I don't know if it's right or wrong, how to pick up this collar right here, how to pick up that thread. So what I've done is I've set it in the chuck. I've got the half nut disengaged, and I come in and I want to get the chuck snug, but I want to be able to spin it. So that's pretty good there. There's a little, David put a pipe wrench on this thing when he was frustrated. But, oh, you guys in the way. God, let's see. Oh, I'm all the way back. That's good. Okay, so we got to go out. Let's see if we can get by you without disturbing everybody. And we should be. So what I want to do is get in the bore. See, I hit it right there. Still catching it. It's because I went too far. I can't see what I'm doing here with you guys. So I have the lathe shut off so that we don't have to listen to the motor generator. So let's see where I'm at right now. There we go. So I'm in. Okay. And what I'm doing now, going to do, is I'm going to bring the tool towards me and engage the thread with the tool. And at some point, we're getting close. The part is going to thread onto the tool. Which it just kind of did there. And so with playing with it, it's kind of hard behind the camera here. You can feel the tool pick up the thread and just slowly keep pulling it in. Since this is almost a full depth cut there, it's starting to follow it now. You can see it right there, how it's definitely, I can't move the part, and it's following the tool. I bring it out a little bit more to get it better, and it'll take it to a point where it will actually lock on the tool. Starting to get tight. Take it back just a hair. There we go. Okay, so I'm in the thread now. I'm pretty solid and pretty good in the thread. So now I got to engage the half nut, and then I'm in the thread. So let's see, let's flip this guy to 0 so I know where I'm at. And now we just take the carriage and move the carriage to pick up the half nut. Let's see, which way do we want it? I think we're going to go this way. It's the shorter distance. I don't really want to go that way. Unfortunately, I didn't have the carriage lined up that good on the half nut. So right there, we're in the half nut, but I don't like that. So how do we solve this? Okay, we go back and we thread this guy in some. Now let's see what we did. No, got to thread it out some. So I just don't want it so deep in the chuck. So I continue to thread it on, get to my half nut. Come on, baby. We're almost there. Almost there. I want a little sticking out. There we go. So now you can see by moving that, whoop, I think you can see there with the glare that I'm on, wherever the glare is coming from, that I'm on the number 2 there. So now I can lock the half nut, move you guys around there. Half nut's locked, so I'm in the thread and my machine is set at 8 TPI. So from there, let's come back up here. Now I need to back the tool out. Back the tool out. And I can come out. I can't come out because the half nut's locked, right? So, let me back you guys up a little bit. So, unlock the half nut. Come out of the part, and now I can pick up any of the numbers here. So we're back locked in, and we're ready to start threading again. And I'll just go in and start picking the thread up, and hopefully size it each time as I go, and see if we get a successful thread cut so that this guy will fit the shaft. Okay, power up the lathe. Moved it back to my 0, but I'm going to go in, go back out, and let's go out about 30 thousandths just to check it. We made a little cut there. see that I don't have to worry about the depth of cut towards the chuck. The ELSR shuts it off each time. Half nut stays engaged. Certainly simplifies. Almost back to where we had engaged. Best we're getting just a little cleanup right now. I'm going to take it till we actually get a cut. Getting a little shavings. There we got a cut. Go back in, no change. Pick up the tool pressure. Still cutting. No change. Still getting some cut. The question is, to go too far. Okay. Marking the cross slide, pull the tool out, and I've got my actual set right here, and I'm set right there, and I'm going to pull it back 1, 2, 3. and go get the shaft and see if we've got a fit. Okay, when I went out to get the shaft, I flipped on my air compressor. And fortunately kicked on for you guys. Alright, let's see how close we are. Now this is the one that would only go in and almost make full engagement, and then it would lock up. There it is. It's locked up again. So, got to go deeper. Okay, so we put the tool back in place. We lock the tool in place, and we take our compound back to where it was. And we should be golden. Power back up, and let's half nuts engaged. Everything's ready to go. So we got to go a little deeper. Go ahead and make a pass right where we're at. Another pass, and we'll take a little. Cutting threads there. Tool pressure. Made some good cuts there. So let's check it again. This guy's back. 1, 2, 3. Tool out of there. Give it a little air. Come on, baby. Get in there. You can see the play. Come on, honey. Come on, honey. Come on, honey. No, we're still not there. Still wants to lock up. All right, go back again. And it's still good and tight. All right. Tool's locked. Go back. Power back up. we got some chips at the far end there. Still cutting. Haven't changed the compound per se. Well, as you saw in the note, my camera lost the battery, and so we're back over on the bench. I did have to make another three passes, I think, pulling the part back, checking it with the shaft. But there it is. There's the last one that I cut, and here's my first one. A little bit of rock. Here's my second one, less rock. Here's the last one, just about negligible rock. There's a little bit there. But not being a hardhead and taking my tailstock off so I could fit the shaft to the thread, it came out successful. And this was picking up the existing thread. So I hope you guys enjoyed that. I've learned a lot, upped my confidence in being able to do this stuff, and maybe take on the rusty boy there next. But thanks for stopping by the channel, and appreciate it, and see you again on another Screwy Tuesday.